I'm really glad to be here. This is my first time in Paris, and I've had a lot of fun exploring your city, and you're all very lucky to live here, except for the traffic situation. But hey, we can't all be perfect. I'm Eileen Uchitelle. You can find me anywhere online at the handle Eileen Codes. I live in New York, but not New York City, slightly north. So I guess I'm not as used to like all of the traffic stuff because I live like in the suburbs, but not these suburbs, like way out in the mountains. I work at GitHub. I'm a senior systems engineer on the app systems team, which just said we do lots of systems stuff. So we work on Rails and Ruby and how they interact with the GitHub application. Like I helped work on the Rails 4.2 upgrade. We got 5.0 green and we're going to 5.2. One day we'll be there. I'm on the Rails core team. For anyone who's new to the Rails community, the Rails core team is responsible for releasing new versions of Rails, deciding what goes into the next version, and mostly making sure that our community is welcoming and we keep improving Rails to where it's supposed to be. So if you've been in the Rails community for any amount of time or just browsed Reddit, you've probably heard the phrase, Rails doesn't scale. I've heard it on Hacker News. I've heard it from VC people. Recently, I heard it in the misguided Vanity Fair article about Twitter with the claim that they couldn't effectively combat harassment because Rails is just Fisher-Price software. It's funny that they called it that. I know they meant it as an insult, saying that Rails was for children and not serious adults with serious web apps. But Rails and Fisher-Price are alike in that they are robust, well-designed, and unforgettable. The interesting thing about Rails getting a bad rap for not being scalable is that it's taken many companies to a scale they'd never dreamed of. If Twitter had tried to build their app at the scale it is today, they would have been bankrupt before they had a proof of concept. And the reality is that Rails does scale, it just doesn't scale easily yet. Historically, Rails hasn't done a great job at making scaling easy. While we pride ourselves on developer happiness, we were missing the mark with scaling and falling short. In this talk, we'll look at ways in which Rails was not scaling easily and what we're going to do about it. I want scaling Rails to be as enjoyable as running the Rails new command. Scaling means different things depending on who you're talking to or what your app is specifically supposed to do. For the purpose of this talk, scalable means that linearly over time, an application's growth in code and data and traffic doesn't change how well it performs. Rails can't take on scaling every part of your web application, but there are two important areas that I want to focus on. The first is, when you're scaling your application, your test suite shouldn't start to block development. As an application grows, new code shouldn't cause more friction. Developers should be able to prototype and build features quickly without being hindered by the time it takes their test suite to complete. While we've made improvements to test performance in the past, we haven't had a solution for concurrent testing. The other area that Rails was failing to scale was your application should be able to handle increased data and traffic over time. The database shouldn't just crash because you got more users or because you have a lot of data. It should be easy to distribute the load on your database as your traffic increases. Rails has had support for multiple databases, but that support is undocumented, hard to understand, and difficult to implement. Rails can't take on every part of scaling a web application, but we can improve developer happiness around these two main issues. My goal is to tackle these two problems to make Rails 6 scalable by default. Scalable by default means that it's easy for engineers to scale their web application without having to use outside dependencies or spending hours writing a custom setup. Scaling your web application doesn't have to be hard, and Rails should be able to take on at least some of that burden for us. Some of you may be thinking, hold up, wait, Rails 5.2 just came out, why are you even talking about Rails 6? Well, major versions of Rails allow us to reconsider what's possible. It's going to be a long time before Rails 6 is out, and I want to share my plans with you. In the past few months, I've done a lot of work to refactor Rails and add features that make scaling easier. We'll look at work done to speed up your test suite and tools to improve multiple databases to make sure that scaling is simple and intuitive. So the first feature I'd like to introduce for Rails 6 is parallel testing. The parallel testing feature will allow you to run your tests concurrently using either forked processes or threads. Parallelizing test suites is an important part of scaling your web application because as you add more code, the more tests you will add, or at least should be adding, and your test suite will become slower and slower over time. You can mock a bunch of calls and ensure that you're not doing any external requests or handling large data sets in your tests, but that's still not going to speed up the time it takes for 10,000 tests to run linearly. Parallelizing large test suites can significantly reduce the amount of time engineers need to wait for builds to finish. A lot of other companies like GitHub and Basecamp and Shopify have been writing their own parallel testing implementations for years. The problem with this is that we're not sharing our ideas with each other or the community in some cases. Rails is popular for taking the complexity out of your application and turning it into reusable generic chunks of code. By adding parallel testing to Rails, we can reduce the complexity of Rails applications, set a standard for parallelization, and make it simple to scale your test suite. Earlier this year, I worked with Aaron Patterson to write the parallel testing feature in Rails based off of our parallel testing infrastructure at GitHub. While inspired by the code in GitHub, the Rails version has been rewritten to have a much smaller footprint, be a lot more generic, and a hell of a lot easier to use. Rails parallel testing feature also supports multiple databases right out of the box. This was a requirement for us since we use multiple databases at GitHub in all of our environments. The concurrent test runner in Rails 6 can parallelize your test suite by using either forked processes or threads. First, we're going to take a look at the implementation for the forking parallelizer. Forked process parallelization is implemented in Rails 6 using distributed Ruby, also known as DRB. It's a distributed object system that can be implemented with zero dependencies, and it's part of the standard library. Parallelization is invoked in your test helper with the parallelize method. This method takes a number of workers that you want to fork by. Parallelization with forking lives in active support and is backed by Minitest's parallel testing feature. When you start your test suite using the forking parallelizer, the testing parallelization class will be initialized with the number of workers that you requested. Parallelization in Rails is supported by Minitest, so once this class is initialized, all the other methods within the class are actually called by Minitest, not Rails. From here, Minitest will call the start method in the parallelization class. Start sets an empty pool array to a block that forks the processes based on the queue size that you requested. Start then calls this after fork method. This is provided so that active record can hook into the parallelization and create databases for each process. Start then calls creates a DRB object which represents the queue of work to perform and will maintain a reference to the DRB server. That DRB object queue variable is used in this loop to split the work for each process. Inside the loop, Minitest's run one method is called, which will run the tests assigned to each individual process. Minitest will return a result, and the queue variable then calls record. Record sets the reporter and the result so that at the end of the test suite, each process can report whether the tests in that process passed or failed. And at the end of the start method, we call a run cleanup hook, and that's used by active record to clean up those temporary databases that we created in the after fork hook. And finally, Minitest calls shutdown, which will empty the queue and wait for the processes to terminate. And that's basically the entire internal implementation of fork processes in Rails 6. As you can see, it's really small and it's only about 100 lines of code. If you didn't follow any of this, though, you don't have to worry about it because you won't need to know any of this to use parallel testing in your Rails application. So for newly generated Rails 6 applications, parallelization will be automatically included in your test helper. And for upgraded applications, you only need to add a call to parallelize in your test helper. The parallelize method takes a worker's argument that accepts an integer. The default number of workers is 2, which means that Rails will automatically fork your tests into 2 processes and create a database suffixed with the worker number for each process to run your tests against. The databases are generated after the processes are forked in that after fork hook that we looked at earlier, and they're automatically cleaned up with the run cleanup hook when the processes are terminated. So Active Record does all of this work for you, and you don't even have to worry about setting up your databases. Active Record already knows how to do it because of these forks that the hooks that we added. The other type of parallel testing for Rails 6 provides is threaded. You're going to want to use threads over processes in a few cases. The first is if you're using Windows, because Unix sockets aren't supported. Unix sockets that DRB relies on are not supported by Windows, or they might be in like one of the very new versions, but older versions don't. You'll also need the threaded parallelizer if you're using JRuby, because JRuby uses threads. And lastly, you'll want to use threads if your tests are I/O bound. Tests that are I/O bound will be faster with threads because they won't be waiting for processes to close before the next thing can happen. The one caveat, though, is if you're going to use a threaded parallelizer, your code has to be thread safe. And I don't know if you've ever checked your code base, but it's really hard to make it thread safe. The parallelize method takes an optional second argument called width that defaults to processes. To use the threaded parallelizer in your application, just set width to threads. It's that simple. If you're using JRuby, when you generate the application, it will automatically be set to threads, so you won't even have to do this. The parallelization setup and teardown hooks are not supported by the threaded parallelizer because it only uses one database and we don't need it. One thing to keep in mind is that running tests with the same suite cannot use different methods of parallelization or number of workers. You can't split half your tests into threads and half your tests into processes unless you make those 2 separate suites and 2 separate CI builds. Threaded parallelization in Rails 6 uses Minitest's threaded executor. One of the differences between the implementation of the forked process parallelizer and the threaded parallelizer is we didn't write any of the code for the threaded parallelizer. Minitest's built-in parallelizer uses threads, so we simply just added a conditional that initialized that executor instead of the Rails parallelizer. So Aaron and I didn't originally want to implement a threaded parallelizer because threads are really hard to get right. But I really, really wanted to support threads out of the box so that we could make sure that we supported JRuby and Windows users. But a funny example of why threads are hard came up while Aaron and I were working on this feature. So we were pairing, and all of a sudden, some weird stuff were happening. We started seeing random failures in test builds. Some runs would pass, but 90% of them would fail. Running a single test always passed, so we knew that it had something to do with concurrency, but we weren't sure what. To look deeper at the problem, we hacked the test log to display the connection ID for each call to the database. Each thread should be connecting to the database with a unique connection ID. But what we saw instead was quite opposite and wrong. Each thread was connecting to the database with the same connection ID. And Aaron says to me, "This is so weird. It's like all the databases are using the same ID. We seem to have a connection isolation problem." And as he said those words, I knew it was suddenly all of my fault. I realized in that moment that code I wrote a year ago in Rails was coming back to literally haunt me. So how many of you in this room saw my talk about system tests at RailsConf last year? I don't. I'm raising my hand, but I didn't see my own talk. Well, when I implemented system tests, I wanted to do it in such a way that we didn't need to use database cleaner anymore. The underlying problem was that when system tests are run, Rails opens a connection to the database on one thread, and Capybara boots a Puma server that opens a second thread and second connection to the database. This meant that when doing system tests, the Rails thread and the Puma thread couldn't see each other, and we would get inconsistent data between test runs because the transaction on the Rails thread didn't know about the Puma thread to roll it back at the end of the test. So the way we fixed that problem was to force each thread to use the same connection ID. Do you see where I'm going with this? The change that I implemented to fix system tests is the exact change that broke threaded parallelization because the change required Rails fixtures to tell all of the threads to use the same database connection. So with parallel testing, we want the exact opposite of that behavior because the threads aren't trying to share data and transactions like system tests are. For effective threaded concurrency, each individual thread should maintain its own connection to the database so that the threads aren't influencing the data on each other. Luckily, since I implemented the offending code, it was easy to find and fix the problem. I simply just added the ability to configure the setting internally, so if you're using the threaded parallelizer, threads will each open a separate connection to the database, and system tests will continue opening only one connection. This does mean, however, that system testing is not yet possible with threaded parallelization. We're working on fixing that, but for now, if you want to use it with your system tests, you can use processes. Running your parallelized test doesn't require any extra work on your part. Simply run Rails test like you normally would, and Rails will handle the rest for you. If you're interested in the PR for the parallel testing feature, you can check it out on GitHub. Parallel testing is going to be a great feature for improving the speed of your test suite. I'm really excited for this feature, and I hope that it helps you scale your application's test suite so that you can focus on deploying code instead of waiting for CI to finish. So now that we've got your test suite running faster, let's take a look at another way Rails wasn't handling scaling well today. And that's whether your application can handle a spike in traffic. I'm not talking about DDoS traffic. For that kind of spike, you want to use an outside vendor or hire experts that know what they're doing. What I'm talking about is trying to scale your web application because Justin Bieber came along and started using it. You need to scale fast, and you need to scale yesterday. I've been in these situations before, and it's not fun. You're just waking up, you haven't even had coffee, and Nagios is just like yelling at you, and you realize that your single primary database isn't cutting it. There are too many reads and too many writes, and you know that your application your database is about to take your application down. It's at this point you know that you need to split tables off your main MySQL cluster. You need read and write and read-only databases, you need replication, and you need more capacity. Your single primary database isn't going to be good enough anymore. Rails has historically had support for multiple databases in that you could do it. But that it's hard, it's really hard. It's so hard that it took me 3 hours to build multiple databases into a demo app in Rails 5. The reason that it's hard is that Rails just isn't setting a standard. The underlying plumbing works, but we're not exposing it through good documentation or the tools that you need to make it easy. So the second Rails 6 highlight that we're going to talk about are improvements that we're making to multiple databases in Rails. While these aren't fancy brand new features like parallel testing, it's a really important part of scaling your web application. Rails for a long time, has had support for multiple databases, and thanks to work from Arthur Neves and Matthew Draper, Rails 5 is a ton easier than it was in Rails 3 or 4. However, when I set out to build that demo application, I quickly realized that there's a lot missing. So let's take a look at an application with multiple databases, and along the way, I'm going to point out where Rails is failing to make it easy. Let's say we have an application with 2 databases. One is our primary database that has a flowers and peoples table, and the second is an animals database with a cats and dogs table. By default, Active Record knows about the primary database and connection because that's attached to Active Record base. We need to tell our application how to connect and talk to the animals database when we're on that dog or cat model. However, before we get started setting up our application, we already have a problem. Best practices for multiple databases aren't documented in Rails. We have no documentation for how to set up your database YAML, your models and connections, your migrations, or the rake tasks for the second database. So we're going to have to figure out how to tell our application about that other connection ourselves. You can tell the application about the animals database by adding a second entry to your database YAML. Multiple database connections per environment should use a 3-tier config like this. The 3-tier config lets us group all of our databases by their respective environment. This leads to a cleaner database YAML and makes it a lot easier to understand how everything works together. So primary is the default for our main database. This represents the original production DB that has the peoples and flowers table. And then we have our animals database entry, which will hold all the information for the animals database. Now that we have that database config set up, we need to tell Active Record where the migrations for the dogs and cats tables live. It doesn't know by default. So I've worked with migrations that deal with multiple databases before, and there's a couple ways to do it. The way we do it at GitHub is we hack our migrations to set the connection at the beginning of the migration. It's really messy, and it requires knowledge of internals, and I think it's the wrong way to do it, so that's not how I did it in my demo application. My preferred way is to put all of the migrations for the animals database in their own directory. It's cleaner, it's easier to find them, and it's way easier to group migrations by connection rather than having to edit every single one of your migrations to change the connection. So for this app, I moved all of the dogs and cats migrations into a directory called animals migrate. However, to use this way of handling migrations, we're going to need to set the migrations paths anytime we call migrate. This works fine for custom rake tasks, but it's impossible to use with the existing rake tasks because the migrations paths is a class method on the migrator class instead of a method on the connection instance. So this means that we would have to set the connection, we have to set it every time that we're going to call a method that relies on the migrations paths, which is a huge pain. So we've discovered the second problem with multiple databases in Rails. It doesn't really support migrations for multiple connections. You can write a database task that will run the migration for you, but any Rails internals that depend on migrations have no awareness of any connections outside the default active record base connection. So the next step is, so now that we know that our migrations don't work, the next step is setting up the animals connection for the dog and cats models. First, we create a new base class. You can name the base class anything, and in this app, I just called it animals base. For this to function correctly, we need to set the abstract class to true. This setting tells active record not to use the implied STI table from the parent class with the child classes. For example, we don't want the dog model to go looking in the animals base dogs table. We want it to look in the dogs table. And so this tells active record to ignore the animals base namespace. Then we need to establish a connection to animals. And now that our base is set up, we just need to change our child classes to inherit from animals base instead of application record. This tells Rails which connection to use when you call dog.new or cat.find. While we discovered some problems with multiple databases, it seems like this is kind of easy and like we already know the problems and it can't be that bad, right? Well, the problem is that if you tried to do anything at this point, you'd find that the rake tasks don't work for the multiple databases. The tasks only know about active record base, so they only know about the primary database. They don't know about the animals database at all. And so create, drop, and migrate will only operate on your primary database, and that means that we have to write all of the rake tasks ourselves. Writing create, drop, migrate, schema dump, schema load, and all the other tasks that you rely on is extremely time-consuming and super tedious. This is something that you shouldn't have to do. If Rails can create the rake tasks for the primary database, why can't it create the rake task for your animals database as well? So after I'd created all of the rake tasks, I was like, great, I spent 3 hours doing this, and I am done, and it's going to work. And so I went to run the create task for the primary database, and my application threw an error saying the production database wasn't configured. I double-checked my rake tasks. I stashed all of my work except for the 3-tier config to double-check that I hadn't done anything wrong. And so after some debugging, I found that default connections just don't work with the 3-tier config in Rails 5. Basically, it's broken. So when you call rake db create, it first loads the active record initializer in the rail tie, which calls establish connections with no arguments. This is where Rails will try to establish the default connection to the database. In a standard application with a single connection config, Rails will assume that you want the database that corresponds to the environment you're in. So if you're in development, it'll just pick the development config. But when you have a 3-tier config, Rails doesn't know which one was the default because there are 2 or more per environment. So for our case, we have a primary and animals. Which one's the default? We know that it's primary, but Rails has no idea because we've never told it. So we've now identified 4 areas where active record is making scaling your database very hard. There's no documentation, migrations don't work, database tasks don't exist, and finally the default connection doesn't even work. So at this point, I realized that the multiple databases in Rails applications is really, really hard. I know what I'm doing. I've done this before. I've worked on multiple applications that use multiple databases, and I still couldn't set it up quickly or even get it to work in an application. Rails wasn't meeting the basic criteria for making scaling your database easy or even possible. So the scope of this came from a project where I was like, I just want to upstream some of GitHub's multiple database behavior to Rails. This project had grown enormously from this would be a few things that I want to upstream to being a massive yak shave, except for instead of 1 yak, I have 3 massive yaks to shave. So each of these problems was going to be time consuming, and there is no easy way to solve any of them. It's really easy in situations like this to get super overwhelmed and frustrated. And believe me, quite a few times I'd wondered why I'd even tried to upstream GitHub's multiple database behavior to Rails at all. But then I remembered that I had applied to speak at RailsConf, and then they asked me to keynote, and you can't really bail on the thing that everybody wants to hear about. So I took a step back, and I identified each of the individual problems, and I thought about what I wanted to fix first. So I decided first to fix the migrations for multiple databases. It might seem kind of weird to fix this first, but it doesn't make sense to start with documentation because the other 3 acts were going to change how multiple databases work in Rails. And 2, I needed the migrations to work so that I could actually finish the parallel testing feature first. So I knew that they were going to work better once the migration code was fixed, so I focused on this. It was also, weirdly, the smallest YAC. So previously, if you wanted to put your migrations in a separate directory, you had to set the migrations paths before you called migrate. This is fine if you're calling migrate directly, but if you want to rely on any Rails internals, it becomes literally impossible to set the path since there's no way to tell Rails what migrations paths to use except for on the class level. So this means that your application is always responsible for telling Rails where the migrations live instead of Rails being able to ask, hey, where are my migrations? So I decided the best way to fix this was to store the migrations paths on the connection instance instead of on the class so that Rails could ask the application where migrations lived instead of having to be told by the app every single time. So to accomplish this, Aaron and I refactored how the migrations paths work, and you can now set the migrations paths in your database YAML underneath the database that you need to change. All you need to do in your app is to change your database YAML migrations paths for the animals database to db animals migrate. If you don't set this field, Rails will just assume that it's db migrate. So this refactoring moved the information for the migrations paths from the migrator class to the connection. So this means that this change allows active record to ask the connection what migrations paths it should use. Before this change, this wasn't possible at all. We always had to tell it where they lived. So this looks like a very simple change, but required a medium-sized refactoring to accomplish. Aaron and I drastically reduced the private API from the migrator class, which allows for more flexibility in controlling where migrations are run from. Looking at refactoring PRs aren't fun at all. So for conference talks, they are fun for you on your own, but not in conference talks. So you can check out the pull request on GitHub to see more about how that worked. So now one YAC is done. It's time to move on to the next one. The next thing I wanted to fix was changing Rails so that you no longer had to write the rake tasks for your new database. So one of the hardest parts about multiple databases in Rails 5 is that you have to write all of the rake tasks for your animals database. This is extremely time-consuming and something Rails really should be doing for you. My goals with this implementation were to make the database tasks intuitive and predictable. There were 2 problems with the existing tasks. One, the existing tasks create, drop, and migrate would only create the primary database. And 2, there are no namespace tasks so that you could do something like drop the animals database or migrate the primary. So you just always had to do all or nothing. I wanted the existing tasks for create, drop, and migrate to automatically run for both the animals and primary database. With a 3-tier config, it was only running for the primary database. One of the challenges of dealing with a 3-tier config is that a lot of the code in Rails just assumes that we have a 2-tier like the standard database YAML, and that a config hash is tied directly to an environment. But when you have a single database per environment, Rails will simply just select a single configuration hash that corresponds with the requested environment. But with a 3-tier config, requesting a configuration hash by environment will return all of the configs for that environment, so we just don't know which one to pick. With the 3-tier config, we also don't know how many databases there are per environment or what the namespaces of those are. Configuration as hashes are an extremely inflexible data model because Rails can't easily select the animals database for an environment because Rails has no idea what the namespace is. To solve this problem, Aaron and I decided to internally convert the hashes to objects so that we could ask them questions and more easily manipulate the data. We created a new class called database config. Yeah, I thought I renamed it to database configuration, but then that's fine. This class is initialized with an environment name, specification name, and a config hash. The returned object looks like this. Now that we have this object, we can ask it questions like, what environment is for this config? What specification name is associated with this configuration? and what config hash is associated with that database. These objects are created by passing the entire database YAML to a method called dbconfigs. This method walks all of the configurations in the database YAML and turns them into database config objects. Now that we have these objects, it's easy to manipulate the data model. We can collect the configs for an environment using a new method called configs_for. This method will collect all of the configs for the specified environment by iterating over the objects returned to dbconfigs. So in the case of our application that we looked at earlier, if we pass production to configs_for, we get an array of database objects for the primary and animals database. By converting the hashes to objects, we have more flexibility and control over the returned data. We can ask the objects questions or enumerate over the returned database configs with group by or find, giving us the ability to more easily manipulate those objects. So let's take a look at how we use those methods to fix the database commands. In Rails 5, the migrate task looked like this. It simply loaded the config and called migrate. Because it relied on the existing database connection, this method would only migrate the primary database in a 3-tier config. To change this to migrate both databases, we needed the configs_for method to iterate over the databases and migrate them. First, we pass the Rails environment to the configs_for method, which will collect all the configs tied to that environment. When using a block, configs_for will return a spec name and a config, because we already know the environment, so we don't need to return it. Then we establish a connection using that return config, and then we can call the migrate method, which will migrate the databases. Because of the migrations path refactoring, Rails knows exactly where your migrations live, so it can run the migrations for the primary and animals database respectively without the task having to be told where the migrations live. The changes for drop, create, and migrate are basically the same. Collect the configs for the requested environment, loop through them, establish a connection, and perform the requested action. Now that the default tasks operated on the database in a predictable way, it was time to build the dynamic tasks for each database in the configuration. I wanted the tasks for each database to be easy to discover and simple to use. To do this, I decided the best way was to suffix the database commands with the database namespace. This way, they're intuitive because they read like English. Hey, database, create animals. And they're easy to discover because they show up in the rake tasks list. These tasks are useful if you want to operate on just one of your databases for a specific environment. This would allow you to drop just the animals database or migrate just the primary database in a case where you might need that behavior. This gives you the same flexibility in a multiple database application that you have in a single database application, and that's really, really important. To accomplish this, we collect all of the spec names using the migrate namespace and loop through all of the specification names to create the namespace task, like primary or animals. Then using the spec name and the environment name, we request the configuration with config for env and spec, which will return a single database config object that corresponds to the environment and specification name. From there, we can establish a connection using a 3-tier config so that we're attached to the correct database. And finally, we migrate that database. This doesn't look complicated, but trust me, figuring out all of the required pieces and refactoring that we needed to do to fix this took a really long time. I'm not going to show you all of the tasks because they're generally the same. For each database command, we create a command that loops through the configs, creates the namespace of the tasks, and calls the methods for that task. If you're interested in the PRs for the majority of this work, you can find them on GitHub. Fixing migrations and adding improvements to the rake tasks drastically improves the experience for multiple databases in Rails. These changes create an intuitive experience for working with multiple databases. There's still a ton of work to do to make multiple databases truly scale in Rails, but these changes are going to make a big difference. As you know, we still have one yak left to shave. The fact that default connections for 3-tier configs don't quite work. I added a Band-Aid fix for this, but it's like, it works, but it's totally wrong. It's a mess. I tried for a while to force Rails to work the correct way, but then after a while I realized that what I actually have to do is completely refactor active records database management handling to use the config objects that we looked at earlier. This is going to allow us to more easily select the config that we actually want to connect to, and will make everything a lot cleaner. This is a huge undertaking, however, and I talked about this in April at RailsConf, and I'm still not done. So that tells you how much work it is. Connection management in Rails has morphed from like this slightly larger yak than the other yaks into my personal white whale. One day I will defeat it, but that work is neither complete nor interesting to look at. I hope that next year or later this year I'll be able to talk about all of the features that were possible because of the refactoring that I'm doing. It's really going to open up our possibility for changing Rails and like making it a lot more flexible for database connection management. Later, when I'm done with that, I want to add some APIs for read-write splitting, some performance improvements, and that documentation that we talked about earlier. It's still not there. My hope is that this work that has been done so far on the connection management is going to further inspire changes to scaling the database side of our Rails applications. So a few months ago, somebody asked me, aren't you like concerned that Rails is just going to become super bloated with all of this scaling code? This is a valid point because most apps don't need GitHub scale. But when I look at the ways in which GitHub has forced Rails to scale over the years, I can't help but wonder, what would Rails look like if we'd upstreamed these features 5 years ago? Would more apps be using parallel testing in multiple databases? Would everyone still be saying Rails doesn't scale? Or would we instead be asking, how can we make Rails scale even more? So this past year at GitHub, I worked on upgrading our application from Rails 3.2 to 4.2. Through that work, I got to see all of the parts of GitHub's stack, from Git code to wikis to gists to pull requests, GraphQL, database infrastructure, deployment tooling, and CI tooling. I got to see all of the decisions made over the last 10 years, the good ones and the bad ones, that scaled GitHub to where we are now. I know that we're not the only ones that forced Rails to scale. I've worked on custom multiple database setup and parallel testing at other companies before GitHub. I know that Shopify has their own multiple database and parallel testing setup as well. I also know that I broke it with that refactoring that I did, so I'll fix it, don't worry. I started to wonder why we all built the same tools, but we weren't sharing with each other. And I think that comes from when we, the royal we, I'm not blaming anyone, think our scaling problems are unique and special. This thinking means that when we're tackling problems in our application, we tend to look inward for a solution instead of outward. We've got to fix that bug or that performance issue. We need multiple database and Rails doesn't support it. Our engineers are complaining about CI time. We need a fix, and that fix needs to be done yesterday. These kinds of emergencies cause us to spend time writing Band-Aid fixes instead of building a scaling solution upstream. When we're in a stressful situation, it's easy to say, let's just build it in our app. We can always come back and fix it right later. But we all know later never comes. And these patches have a way of taking on a life of their own, and they grow and they grow and they grow until we don't know where our app ends and our framework begins. Our applications begin to resemble a game of Jenga. One wrong move, and the whole thing comes down. And when this happens, we start to think that maybe they were right. Maybe Rails doesn't scale. But in reality, what's not scaling is the code that we wrote. Instead of building scaling solutions upstream, we build more and more on top of our fragile application. When we build tools while only looking inward, our code becomes specialized, rigid, and impossible to change. The tools we built stagnate because they don't benefit from community improvement. On top of that, we find ourselves building the same tools over and over and over again. There's a better way, though. We need to start looking at our problems from an upstream first point of view. The first step is to admit that our applications aren't special. If our apps are special, we'll all need to scale at some point, so why are we hoarding solutions to those problems? I've seen many companies reinvent parallel testing, hack together multiple databases, and force their apps to scale inside their application rather than building a scaling solution upstream. And I'm not claiming that upstreaming is easy, but when we see ourselves building the same patterns over and over again, it's time to ask, is this unique to my application? And when it's not, it should be upstreamed to Rails or built as open source. Upstreaming your code first has many benefits to your organization and community. Upstreaming your tools forces you to write generic code. This prevents your application from becoming tightly coupled to those tools, which will keep your application more flexible and easier to change. Less like Jenga, more like Legos. Upstreaming scaling solutions means that you're training your future workforce. Your engineers don't need to learn how to implement multiple databases for your setup because your setup is everyone's setup. Rails will set the standard for scaling databases so that you don't need to redefine that standard at each new company you work at or each new application that you build. And lastly, an upstream first mindset means that we're giving back to the community and that community gives back to you. When you push your code upstream and you stop porting solutions that aren't unique, others are able to, oh my God, this bug really was interested in being a part of this talk. Sorry. When you build a scaling solution upstream, the other people are going to come in, they're going to use your tools, and then they're going to improve them. So this is what makes open source super magical. I know that by upstreaming our multiple database handling, that not only will other companies benefit from it, they're going to improve it for me too. That's less work I have to do. And working by yourself in a vacuum isn't fun or productive. When you share your experience and your code with others, you learn from their experience and they learn from yours. For years at GitHub, we've been hacking our application to scale, and I felt like it was time that we start giving back and sharing our experience with the community. In order to improve Rails scaling ability, I looked at all of the ways in which we forced Rails to scale at GitHub. I've worked on these tools before, but seeing them at GitHub scale really showed me how much Rails was missing. Over the past 10 years, GitHub has learned a lot from using Rails. We learned where it stands up and where it falls down, and now we're giving back and upstreaming our scaling behavior because we know it's not special. By building these tools in Rails, we reduce the footprint of our application, train our future workforce, and give back to the community. I want everyone who uses Rails to experience developer happiness, not just at the Rails new command, but at 5, 10, and 15 years later. But we can only continue to experience that happiness if Rails is providing the tools that we need to run our applications for 15, 20, and 25 years. So to answer the question, do I think Rails will become bloated with scaling code? My answer is no, because contrary to popular opinion, Rails isn't dying, it's maturing. If Rails wants to continue being the choice for building web applications, we, the Rails team, need to respond to the needs of those web applications. We need to be built not just for prototypes, but for the long term. The path to maturing is to start building scaling solutions upstream so that our users don't need to constantly reinvent the wheel, or worse, look elsewhere. Some may still think that Rails is just Fisher-Price software, but like I said earlier, Fisher-Price and Rails are both well-designed, robust, and unforgettable. We're going to keep adding improvements to Rails to make it more scalable, more resilient, more unforgettable. We'll take your apps from Rails new to Rails scale. And we're going to keep improving Rails until everyone says Rails does scale. But to do this, I need your help. I would need you to go home and look at your applications. What have you done to force Rails to scale for you? What can you give back to our community? Can you make parallel testing faster? Do you have other tools that you built that can be made generic and pushed upstream? Rails is and will continue to be defined by its community. Help us define the future of Rails. Let's make Rails 6 scalable by default. Thank you.